Good morning to everyone. Welcome to this third day of conference. I think we can start with this session. This is a lightning talk session, so we will have 6 speakers and they will have 5 minutes each. So let's start from the first speaker. So the first speaker is Steffen Moritz from Institute for Data Science, Engineering and Analytics. So hi, Steffen, welcome.
Hello, Marta.
He will present us some visualization tool for time series with missing data. So, Steph, you can start.
All right, thanks for having me. I'll directly start. Wait, try to share my screen. You see it? Can you see my screen? Okay, if you don't see my screen, please tell me. So, all right, let's go. So, welcome everybody to my talk about time series missing data visualizations. I'm Steffen Moritz from the Institute of Data Science from TH Cologne. Here, just a picture of me because we can't see each other. And well, missing data is quite a common problem in time series. And especially, for example, if you're dealing with sensor data, it's quite common. And we are developing the ImputeTS package for helping with all kinds of missing data problems. And today I'll be especially talking about plots and visualizations because in our new 3.1 version, these got refurbished. And this version is currently available on GitHub and in the upcoming days also on Jhirad. So the package itself features functions in these 3 different areas. This is imputation, so functions for replacing NAs with reasonable values, visualization, which we'll be talking about, and functions for getting missing data stats. So a short wrap up, the imputation functions, they go from simple to more advanced functions. An example would be classical interpolation. A more advanced function would be Kalman smoothing on state space models. The main advantage of these advanced functions is they can deal better with seasonality or trends, visualization, which is updated and we'll be talking now about. And beyond stats, there are also benchmark data sets which can help you with your comparing algorithms and experimenting a little bit. These come in handy. So since we're very short in time, my top 3 time series missing data plots from the package. So imagine you're just starting out with a new time series data set and you know you have some missing values, but you don't know, are they at the beginning, at the end? Are they bunched up together or like distributed evenly over the series? Then you can use the ggplot NA distribution function and it gives you this nice little plot which gives you a very good first overview over your missing values. All right, so far so good. So this is a short first overview, but maybe you want to dig a little bit deeper. So we have different functions for this. For example, one example would be the ggplot NA gap size functions, which basically ranks the different occurring gap sizes. So with gap size, we mean NAs in a row. So it could be there are single NAs in the series, or it could be, for example, for the whole series, it's always 7 NAs in a row. So all missing gaps are always 7 NAs in a row. And if something like this is occurring, this, well, you should look a little bit deeper. Maybe this can give you hints about the root cause of your missing data or something like this. Or these plots for discovering patterns can be quite useful for you. So, okay. But once you dig a little bit deeper, maybe you decide, well, let's do some imputations. Let's replace the missing values with some imputation function. And then we have this plot here. In this example, I used the worst possible function you can use for this time series for demonstrationary purposes. So I used NA_mean, which just replaces with the mean. And you see from this ggplot NA imputation functions, for this time series, this would be a really bad fit actually. So you would use another imputation function, for example, this more advanced NA_Kalman function. And now you see, well, this is way better than the one before. So this ggplot NA imputation functions helps you assessing the performance of your imputation algorithms. Actually, there's much more to the package, which I can't show because it's just 5 minutes, but you can visit our GitHub page. And if you're interested in missing data visualizations in general, there's also the Narnia Vim Wizard package, which are not about missing data in time series, but rather in cross-sectional data, but also worth a look. And there's all the missing data task view, which is a nice assembly of all kind of missing data packages you can use in R. And well, that's it basically for my talk. Hope you enjoyed the talk and hope you get some inspiration and maybe some tools for your missing data problems. And I'm glad if you have questions later on. Well, thank you.
Okay, thank you, Steph. So let's move to the second speaker. So the second speaker will be Thierry. She's a statistician at the Research Institute for Nature and Forest. And the presentation is about the package effects and visualize uncertainty. So welcome, Thierry. The floor is yours. Start the presentation.
So, thank you. I'm not sure I have to turn off my camera. So let's do it like this. So good morning. Our institute is responsible for publishing lots of statistics, and it's becoming more and more important to have a standardized way of interpreting these effects. That's why we wrote the effect class package. The concept is based on the confidence intervals. We start by comparing them with a reference. So if the reference is outside the interval, we have a significant effect. That's of course nothing new, but notice how the two insignificant effects have a quite different width of their confidence intervals. So what we do is we define two more thresholds at the level where the effect becomes important. So once we have an insignificant effect, which has an interval contained between those thresholds, we can state that there is no important effect or no effect. As soon as the one of the thresholds is contained in the interval, then we have an unknown effect. Now the combination of these reference and two thresholds define 10 different classes. And we used standardized text labels for these classes, which you can see at the x-axis. We also define a standardized terminology for each of these classes. For instance, in case of trends, going from left to right, we have a strong increase, an increase, a moderate increase, a stable trend, moderate decrease, a decrease, a strong decrease, a potential increase, a potential decrease, and an unknown trend. Now, our scientists often ask, why don't we use, should we use point estimates and p-values, because that's what we used to do. Well, we'll try to illustrate in this figure that confidence intervals are much more informative in our opinion. This is the p-values are high. In this case, the two rightmost examples have identical point estimates and identical p-values, but the confidence intervals have a strong difference. Now, the workhorse of our package is the classification function. It's you provide it with the confidence intervals and with the thresholds, and then it will return a 10-level classification as a factor with the text labels. If you prefer to have fewer levels, you can use the coarse classification function that reduces it to 4 different levels. And if you're not interested in the direction of the effect, you can use the remove sign function, which yields either 6 or 3 classes. We also have a few ggplot2 add-ons in the package. The stat effect function maps the data into the different classes, yielding a geom point with different shapes. And then you can add the scale effects to map those classes into the symbology, as you can see here in this picture. We carefully designed the symbology so that it can represent both the size, the sort of magnitude of the effect and the uncertainty. You can also see the direction of the effect as well. Then we have something like a stat fan, which uses stat fan plots, a term coined by Britton et al., who suggests to use several equiprobability confidence bands rather than just a single confidence band. So the default uses 3 different bands, so that's 30, 60, and 90% coverage. The fine version uses 9 bands with 10% intervals. We can have this with different geoms. Here are just a few examples, but more details on all possible combinations are available in the vignette of the package. So then I think we can already conclude. I strongly suggest that if you're interested, you have a look at our vignette. All information from these slides is available in the 2 vignettes of the package. And you can find our package code on GitHub. Any comment and suggestions are welcome. The links itself are available through our abstract at the conference webpage. So that was my presentation. Thank you.
Okay. So let's move to our third speaker, that is Gabriele Galatolo. He is a scientist at Code SRL, and he will present us the package aRangodb. So please, Gabriele, if you are here.
Yeah.
Okay.
Hi.
So welcome.
Thank you.
So you can start your.
Okay. Share my screen. Okay. So hi everyone, and in this talk I will briefly show you how we supported our Twitter sentiment monitor platform by use a graph-oriented database. And as an underlying storage system, we use the aRangodb multimodal database, which provides storage capabilities using collections of JSON-like documents, then in key value form, basically. And data from collections can be linked to each other using special documents with reserved keys, underscore from and underscore to create a graph native organization of data. To connect the database and the application, we developed a Plumber-based REST API that use the package that we created to simplify the access to the aRangodb database. And the aRangodb package allowed our user to operate with the database using a tidy syntax to retrieve collections, insert and set documents properties, and to filter out data from collections. Moreover, it is possible to retrieve or create graphs at the edges between documents and find subgraphs by the use of the traversal operator. In particular, the traversal operator returns the relationships between all the documents as a list of adjacency matrix, one per edge type, which allow us to represent multiple relationships between documents as well. Obviously, the package provides also visualization functionalities. And finally, relying on this infrastructure, TweetMood is the application that we developed to monitor the sentiment for selected hashtags or keywords. This is how our current dashboard appears, but under the hood into the database, the data looks like this small selection of tweets and users who wrote them. Anyway, this is only a small part of the graph that contains the most intuitive relationship who wrote what. However, inside the graph, we model other relationships within the data that we can manage and use with our aRangodb package to do even more complex analysis. For example, we can use the part of the graph that models the relationship hashtags contained in tweet to find hidden patterns between hashtags using association rules analysis. Just to give a quick note, in order to do association rules analysis, we need to represent our data in form of separate transactions containing a set of items. In our case, each message will represent a transaction and each hashtag will be an item. To prepare data and transactions list as transactions list of hashtags, we can use the adjacency matrix of the relationship contained in. And since both on columns and on rows, we have all the hashtags and all the tweets identifiers, and considering that the graph is directed, so the matrix is not symmetric, with few operational data wrangling, we can obtain the matrix in the way we need to be in input to the association rules process. And finally, we can obtain the analysis we wanted. In the table, we can see the left-hand side and the right-hand side of the association rules, the supports and all the related information. So it is interesting to note how these rules can be again arranged as a graph that we can use to improve our knowledge base and our database. So using our package in very few lines of code, we prepare data to execute a complex analysis. And this is basically how we felt about that. Okay, so even if we did a lot of things about the package, many others are still missing, so we have a long way to go, but for now, that's all, and this is the end of my presentation. So thank you for your attention.
Okay, so thank you, Gabriele. Very interesting talk. Speaker will be Kirill Muller, that is a consultant for Syngra, and he will present the package DM. So, Kirill, if you are with us, you can join me on the floor. Okay, so hi, welcome. So, okay, let's start with your talk. You can share yours.
Thanks. I need another second. Okay, getting ready. Let's go. So, thank you. My name is Kirill Muller. Today, I would like to give a short introduction to the DM package. DM is short for data model. Data model consists of tables and relationships between these tables. For data analysis, we are primarily interested in the data that lives in this table. With DM, we can consume existing data models, build our own data models, and deploy our data models to production. DM is useful when your data is distributed across multiple tables. These can be local data frames or tables in a database. In the simplest case, it is a container for your table objects, and it can do much more. For modeling and plotting, we usually want a single flat data frame. However, this is not the best format for storing and cleaning the data. The example data model here contains data on loans, together with transactions and orders for a number of bank accounts. It is centered around the account table in the middle. The arrows denote relationships between the tables. Each account is attached to exactly one district. Each account may have multiple loans attached to it, or none at all. Accounts may be connected to multiple clients. Each client may have multiple accounts. If we try to squeeze this data into a single table, we end up with a complicated nested table that still has redundancies. With multiple tables, we can avoid these redundancies. But we have to join or merge the data if we want to have something suitable for data analysis. DM makes it easy to work with relational data models. If your data is on a database, you can connect to it through DBI and build a representation of the data model as a DM object. The DM draw function shows this as a diagram. DM can check if the links between the tables are valid. For example, if there are duplicate accounts or if each loan correctly identifies the related account. DM helps with joins or merges. Forget about join columns, your DM object has the detail. This example is a recursive join that gives all details associated with the loan, ready for modeling and plotting. DM ensures that the returned column names are unique and descriptive. DM is not restricted to working with databases. The collect function downloads the data from all tables in the data model into your local R session, if you can afford it, if you have enough memory. These are just a few examples of using a ready-made DM object. Often your input data is much messier than the previous example. You can use DM to build a data model for yourself too. In this example, we're using the flights data that comes with an R package. This works for any data frame. We define tables, we add keys, and we have a DM object that we can use to understand and clean up our data. Fast forward, after many iterations of data cleaning, when you're ready, DM helps sharing the data so that others can use it. Here we copy the data model we created on a previous step to an in-memory SQLite database. The database, after the copying, is set up in a way that allows efficient joins. DM also offers tools for incremental updates of a database. This is beyond the scope of today's presentation. To wrap up, use DM today, if only as a list of tables. Build data models tomorrow. Share these data models the day after. DM is on CRAN and on GitHub. The slides are available. I will post them to the chat. You can run the code from this presentation in the browser by clicking the RStudio Cloud button in blue. I would like to thank Tobias, Darko, Katharina, James, and the other contributors. Thank you for your help. Thanks Hadley and the Tidyverse team for the groundwork. Also, thanks to Energie360, who sponsored a substantial part of the initial package development. That's all.
Okay, thank you, Kirill. So, the next speaker is Matilde Grecchi. She is head of data scientist and innovation at Zucchetti SPA, and she will present us. So, welcome, Matilde. She will present us to support the sales force of Zucchetti. So please, Matilde, you can start sharing your presentation.
Okay, perfect. I just share my screen. Do you see my presentation?
Not yet.
Oh, it's disabled. Just a check. It's disabled. Do you see?
Not yet. So. Okay, try to close and open the browser again. Maybe.
Okay.
No, not yet. We cannot see yet your.
Okay, I try.
Maybe you can try close and open the browser. Okay. Thank you.
Okay.
Okay, so let's wait for a while until Matilde will join us again. Okay, so I remember in the meanwhile to all the viewer that question for the speakers, you can write it on the chat, and then at the end of the session, we will have the question and answer. So call back all the speakers again on the floor. So then we can ask all the questions that you have. So welcome, Matilde, back. Share your screen.
Okay. Do you?
Okay, no, we cannot see your screen yet. Are you clicking on the?
Yeah, but
like
maybe I try
third,
because
yeah.
I changed browser. Now I'm Chrome, but he
Okay.
asked me to share preference, so I just try to enter
Okay.
again.
So
Sorry.
okay, so maybe in the meanwhile we can go on and then maybe come back. So then I will call the next speaker, that is Nicolas Jhirad. So I will listen for the talk of Matilde after Nicolas. So Nicolas, please, you can join me on the floor. So Nicolas is a senior data scientist at Sync ICT. So hi, Nicolas. So please, you can start sharing your screen and you can start the presentation.
No, not that one. I can use it. Hello, I'm going to talk about logging. So keeping on top of R in high stakes real-time trading systems. I'm not going to bury the lead. I asked a colleague of mine, Aaron Jacobs, Ethereal on GitHub, if I could write to devlog from R. He took a day or two and wrote rsyslog, which is up on CRAN. I want to talk about how this made R in production possible. What is syslog? It's a 40-year-old logging standard that is in nearly every Unix-like system, most likely already in use in your environment. Advantages are we don't track log files. We log to the device. It's easy to forward via config. Devlog can very importantly be mounted inside a container. And if we could write to it easily, then we have no good reason not to write to it all the time. It even works on services like RStudio Connect, which sometimes have difficulty logging for publishers there. Who am I? I'm a data scientist based in the Netherlands on contract. My current domain is sports analytics and sports trading systems. I'm on loan to Crescendo Technology, a firm that builds applications and models for sports books, who consume these models and deliver up-to-date odds on everything from soccer to esports. What is our ecosystem? We have more than 50 internal packages, 40 plus prediction services written in Plumber, 10 plus production web applications in Shiny, and our actual infrastructure is really C# and RabbitMQ with a Dockerized microservice architecture. What do I mean by high stakes real time? Bad models applications lose money very quickly in production environments. Savvy betting groups will quickly identify weak predictions and exploit them. The model's applications need to react quickly, typically under 100 milliseconds. So the question is, why did they let us put R in production? Well, R syslog uses an existing standard. Standardized logging is handled well by many existing systems. We can debug errors without physically having access to the system. This increased the speed of iterations, minimized disruptions, and improved stakeholder confidence during crises. And I have a demo. So I have two containers right here that are running on a VM. So I've got that one right here. And right here is an example. I loaded rsyslog. I set what my mask was. I set some environmental variables that I'd like to log, like host name and my app name. And now I'm going to do something. You can use try catch, or in this case, I used with calling handlers. And if we write these, sorry, that's the whole file. And now look in my container host via journal control. I can see that each one of these logged their location, specifically logged the hash of the container that sent this, the app name, and what we did. We can do this from multiple there. You can see that I tried before and had multiple different hashes. This is really, really important for us because we needed to be able to see what our Plumber APIs were doing when they were throwing errors. We needed to get those errors, somehow trickle up those errors. Once we have these logs, we aggregate them, and for that we use Splunk. We use these for aggregating these logs, developing alerts on top of them, determining performance and examining model output real time, and waking me up at 4 a.m., which rather often happens. Here's actually an example from ours. We can see actually kind of a dashboard here where we have a number of our different services and various timings for those. We also have, this is also used later when we are trying to build training data sets, because we will often build training data sets off of our logs because they are detailed enough that we can see what was called when and how we performed. I want to say thanks to Aaron Jacobs for his wonderful package. Also check out Longairs for RabbitMQ from R, which has been godsend. And Crescendo Technology for really letting us open source and for having a commitment to that. And I remit for the remainder of my time if there is any.
Okay, thank you. Thank you, Nicolas. So
Do you hear me? Okay, perfect. Just share my screen. Okay. I hope you hear me well and see my share presentation. Okay. I can start. Okay. Sorry for the inconvenience before. Just a brief introduction of myself. I'm Matilde Grecchi. I have a mathematical engineer background at the same time. It's more than 10 years that I work on data as a consultant on topics related to new technologies, innovation, and artificial intelligence. During my professional development, I made a great experience in McKinsey & Company. Let's now introduce the topic of today with a question. Is it possible to cross-sell a product considering your customer base? If yes, how can you achieve this? We will find the answer to this question in a mathematical model that we have implemented. But to do this, you must know your customer, their purchasing behavior. For this reason, you have to analyze in detail the data available, data that are your information source, the value that must be objective and incontrovertible of the information they carry. We live in a world with a lot of data, but we have to find the best way to exploit this fundamental source of information. What we have implemented is a shiny web application in Zucchetti integrated in our customer relationship management that is used by more than 100 people at the moment and is deployed through Shiny Proxy in a Kubernetes environment. Here I show you some screenshots of this application. What we have made is to consider, on one end, all the information coming from anagraphical data related to customer in order to create a model that highlights similar features and characteristics between customers, a propensity model. This model allowed us to create clusters of customers with similar characteristics. On the other hand, we analyzed the acquiring behavior of each customer in order to extract pattern of products bought between similar customers and to extract relationship of similarity between products sold, a collaborative filtering approach. Merging these two models, we created an algorithm that per each customer, it suggests in real time the best product each customer would be interested in buying in relationship to his similarity to similar customer and similar products bought by other customers. Then we have asked ourselves how we can evaluate the performance of our sales force. Therefore, starting from a market basket analysis, a statistical approach, we extracted rules, the strong relationship between products that we use to make a rate in terms of coverage of our sales force. This allows us to understand the strength of the link between products. If we see the graph, the shorter is the arrow, the stronger is the link between two products. It means a greater interdependence and complementarity between them. From this, we implemented indices to compare the performance of our sales force to the benchmark calculated globally and for each region. As you can see, the map is colored in different scale of blue. The color of each region depends on the value of the index calculated in order to highlight different performance and coverage of our sales force. To conclude, what we have obtained from a recommendation system is a knowledge more in depth of our customers, a more effective commercial campaigns on target customer, and last but not least, a better retention of them. We have measured a plus 35% of sales with the introduction of this approach to support our sales force. Thank you for your attention, and if you have any question, don't hesitate to contact me.
Okay, thank you, Matilde. So now the question and answers session. So I will call back all the speakers on the floor. And in the meanwhile, I will remind you that, so before starting the question and answer, remind you that there are polls where you can say what you think about the online conference. You can find them on the right tab next to the chat. So please, if you have any comments on the calls, so just go there. So welcome back to all the speakers. Kirill. So maybe we can start for the other. Okay, so let's start from the question. So I will pick up randomly the question I see. So first, this is a question from Mauricio Moreno Zambrano. And he asked, so let's suppose that I have a gap of 4 years in a time series of daily measurements of temperature. Does put TS help me?
Oh, all right. For me, the question. Okay. Well, how to give a short answer, actually. It might help, actually, but you have to see it on a case-to-case basis, of course. As a rule of thumb, it gets harder. The longer the missing gap is, actually, the more the missing percentage is. Temperatures are actually also quite hard because they are not the same each year, because it can shift a little bit. And in general, the confidence, of course, goes down. So you can't rely too much on your imputations. That's actually something we plan for further versions of the packages, to include confidence intervals for your imputations. Maybe this helps. So I can't say generally, it might help, it might help.
Okay. Okay, thank you, Steffen. So now, easy question. Would it be possible to share the slides?
Yes, I've put a link in the chat where the slides are, but I really recommend to have a look at our vignettes, because all the information of the slides is available in the 2 vignettes, and it's a bit more elaborate than a short 5-minute talk.
Okay, perfect. So another question from Thierry Onkelinx. So I think that you can self your question to Steffen, if you want.
Yes, Steffen. I'm wondering if your package handles multiple imputation, or this is just single imputation.
Currently, it's single imputation. Maybe a few words to this. It comes rather from an industrial background, from sensor data. So not like kind of statistical background in the sense of like social sciences or something like this, where you have often multiple imputation because you need it for your surveys and stuff like this. And generally, you can say the concept, for example, maybe you know chained equations from mice or something like this. Don't exactly transfer to univariate time series. The package is actually very specific to univariate time series. So it's an ongoing research question for us if we can transfer the concepts of multiple imputation to univariate time series specifically, but probably rather a long-term project for us.
Well, in my opinion, you really would need it if you want to have correct confidence intervals. So keep that in mind when you're going to calculate confidence intervals.
Okay, so back the floor, I can start with a question for him. So the question is from Stuart. The question is, I deal with lots of data from Dynamics 365, and DM looks like it's going to save my lots of comment question, but if you have to, if you would like to comment on that.
Thank you. I don't have experience with Dynamics. I suspect it might run on a SQL server. We can connect to a SQL server. Feel free to find me at the conference. Let's have a chat.
Okay, Kirill?
Yes?
Kirill, can you?
Yes.
So
Positive.
a question from Alexandro. He asked, can you also create a normal flat local table?
Yes. We have tools for that. We have a function that will allow you to split a table into a parent and a child table, which you then can stuff into a DM object. Later, I realized that there is the unjoin package that does pretty much the same. We're thinking about integrating this into DM so that we can offload this functionality to that other package and not have to worry about this. But that's one of the purposes you can use DM for. You get a bunch of messy data, you normalize it, you establish the relationships, and you have a DM object to work with.
Okay, thank you, Kirill. So now a question for Matilde.
Okay.
So this is a question from Fraser Gray. And first of all, thanks for the talk. And the question to elaborate with us which R packages, frameworks you are choosing to use for your propensity model and collaborative filtering. What are your thoughts on content-based filtering?
Okay, so about this true model, we have all write down all the code from the scratch. So we didn't start from an array package as we used for the market basket analysis that we use the rules package in this case. And then for elaborating the model that you write down and prepare data for this, we use the library H2O to elaborate more faster our model, because we created a specific model for each of our products that Salesforce have available. So this is the complexity, because we can sell more than 100 of different products. So we created a specific model for each of them. So we created a code from scratch, not using a pre-existing package.
Okay, so thank you, Matilde. I know that there are other questions, but over time, so we need to close this session. So please, if you have any other question for the speakers, you can text it back, contact directly them. I just would like to remind you that during the lunch, a lounge about data science, freelancing, and business. So please feel free to join and to. So thank you to all the speakers.
Thank you.
Thanks.
Thank you. Thanks.
Goodbye.
Bye.
Bye. Bye.
Bye.
Bye.
Thierry,